Change of base identities for logarithms. Question 43. 2 over log 8 of a minus 4 over log 2 of a equals to 1 over log 4 of a. Now these are kind of reciprocal of logarithms, and we understand by now that we can use change of base formula to solve them or prove them, right? So let's try to understand change of base formula, which can be modified to write in reciprocal form. So basically, change of base is like this. Let's say we have log to the base a of x, and if you want to change this base from a to b, then this can be written as log b of x divided by log b of a, right? So we can change base to anything. Now look what happens if we change the base to x itself, right? So then what happens? So then what do we get? So then let's again try this formula, and this time we'll change base to x, not to b. Then we get log of x over log of x of a. Now what is log of x of x? It is 1, because x to the power of 1 is 1, correct? So we get 1 over log x of a, right? So do you see it becomes a reciprocal of the log, correct? So that is a huge application of this change of base formula, right? Another application you know is when you change to base 10, you can use calculator. Perfect. Now we'll use this base of change formula and prove this identity. So let's start with the left side, okay? So left side for us is 2 over log 8 of a. So that means 1 over log, so let me write 2 first, 2 is here. Now we're left with 1 over log 8 of a. It could be used, this formula can be used. We can now change a and x position and write like this. So it becomes log to the base a of 8, correct? Minus 4 times log to the base a of 2. Do you understand? That is how we can change, right? Let me show you this part here once again. Let's say we have 1 over log 2 of a, right? Then I can change my base to a. What happens? Log a of a divided by log a of 2, right? Now a of a is 1, so we get 1 over log a of 2, right? So that is reciprocal. Or in a way, okay, I should have started with log 2 of a, right? So log 2 of a, we can change the base as log a of a or log a of 2, right? So we get 1 over log this, right? So that is how the change of base formula comes. Now we can write 1 over log a of 2 as log 2 of a. So this interchanges. That is what I'm trying to show you here, right? So that is how the left side can be simplified. And now we will apply the power rule. Do you see? Power rule is this becomes the exponent of 8. So it is log a of 8 square minus log a of 2 to the power of 4. Now we'll apply quotient rule, correct? So here we applied power rule. Now this, and got this one, right? Power rule was 2 went there, right? And then we'll now apply quotient rule. So it can be simplified as log a over 8 square is 64 divided by 2 to the power of 4 is 16, correct? Now that gives us log a of 64 divided by 16 is 4, correct? Now log 4 of a, we can change the base using this formula, and let me do it once again. I just messed it up here, so I want to do it again to show you. So now we'll change the base to 4, and so we can write this as log 4 of 4 divided by log 4 of a, right? And what is 4 of 4 log? That is just 1. So we get 1 over log 4 of a, and that is our right side, correct? So that is how we can prove this identity. I hope by now you've become an expert on changing base and solving such reciprocal identities for logarithms. Thank you.